Okay, well, for people joining us on the live stream, this is another episode in internal design meeting for our incremental language development efforts for the next version of Wolfram Language. This is kind of the last stop for a bunch of interesting utility language functions before they are released in the next version. So we are looking at some documentation and we are starting with sequence split. Have I seen this page before or not?
Perhaps, I don't remember. We have discussed also sequence replace recently, and perhaps we looked at them together. They are very close to each other.
Okay. So let's see.
So as usual, the motivation for these functions is coming from the string family. So this follows string split.
Right. So, okay, fair enough. I mean, this is what, as we discussed.
Yeah.
Okay, what does so I don't think there's a lot that's controversial here. Are these things knitted or not?
I don't think so. Do you remember, Xavier?
No, they were not.
Okay. Do we consider this experimental or this looks pretty solid to me.
I think so, like sequence replace.
Okay. All right. Okay. So let's see. So let's go ahead and knit this guy. There are no weird cases that we have to worry about here.
No.
Xavier? No? I don't think so.
So between sequences defined by pattern does not include the sequences themselves, right? So that's the same. Okay, so that's pointing to string split here. Why are we pointing? Yeah, I guess that's right. Have we pointed back to sequence split from these pages?
No, I've just updated the backlinks of the sequence family, but not for the other symbols.
Okay. Okay. Well, let's see. So this should probably, yeah, so it should go right there before string split, right?
Yes, exactly.
In fact, I'm not even sure that string split should be. I mean, I think
it's fine there because it's one of the split family.
All right. Okay. Fair enough. Okay. Split by. By the way, did you put keywords in sequence split?
Yes.
I guess.
Yes.
So split by, where do we want to mention it there? We gather by is clearly more relevant. But partition is probably less relevant, so let's put it in there. Okay. And string split, did you point back to sequence split?
No.
I'm not even sure that split itself should be mentioned here. Oh, maybe it could be after sequence split. Okay, now what is yeah, sequence, it does need to be mentioned here.
Probably. Yeah, the other connections are more for the sequence part of it.
I mean, I don't know why. If we're mentioning sequence split, why aren't we mentioning all the other sequence functions on pattern sequence?
Yes, perhaps actually
sequence cases.
Sequence replace and sequence cases are more important than sequence split here.
I would think so. Okay. Subsequences. Not really.
No.
We need to have back point from that. And sequence alignment likewise.
Yeah.
Okay, so let's go to sequence replace and let's see where it is on guide pages. Oh, come
yes,
on.
sequence replace was not added in the guide pages.
Is it new?
It is new.
Yes.
Yeah.
Humph. Where does this go? Well, let's look at list manipulation, see whether we have the sequence family. I see. Finding sublists. Finding sublists. Okay. Rearranging, restructuring lists.
Perhaps we could change finding sublists to sublist manipulation, and we put the
No, but
sequence.
look, I agree, but this has other. This is all extraction things.
Oh, I see.
So what are the two that we were missing? It's just sequence replace and sequence split.
Yeah.
Well, I mean, that seems to me it's in this family here, right?
Yeah, we could add another line there with the two.
Yes. But these are some pretty major functions like join and partition and so on. Well, I don't know whether these make the cut there, or whether we should just add. I kind of think what we should do is add.
I still think that perhaps we can have even a new section with a new delimiter dedicated to sublists, now that we have like 5.
All right, fine. All right, so let's have a section here called finding and manipulating sublists.
Mm-hmm.
And then what we can do is move those guys down there. And maybe we can have a separate line here for sequence split and sequence replace,
Mm-hmm.
I guess.
Yep.
Okay, but now on this page, on the rearranging and restructuring lists page, we probably want to have so there we've got subsequences. Okay, so let's have a section here called
Maybe sequence-oriented operations. We have an element-oriented operation just below.
That seems sensible, yes. I agree. Okay, and we might want to actually point this thing here over to that rearranging and restructuring lists thing as well. So okay. You know, that would potentially allow us to not list all of these here. Where do we even list count here? We don't even list count here because it's list manipulation, so we don't really list that. So I'm going to, let's look back at this, okay? Sequence position. I suspect sequence cases is more important than sequence position.
I agree.
And let's do sequence split here. Or do sequence replace is probably more important. And then just do that.
Mm-hmm.
Yeah.
And then let's point to this page. And now here we can say, so no, this isn't right, because this is a page about, it would not include count and things like that, right? Yeah, so I'm afraid we're going to have to put sequence count on this page here for math and counting operations, right? That for which it's quite relevant, actually. Okay, so that means we have to go down there. Okay, now wait a minute. Sequence position doesn't really belong, unfortunately. Right, sequence position does not belong in finding, well, finding and manipulating sublists it belongs, but it does not belong in rearranging and restructuring lists.
I guess we can organize them by putting all the sequence together or by action, as you are doing now.
Right. Well, okay, hold on. We can, okay, so here we've got, oh, look at this. We've already got sequence-oriented operations right here. And that already goes to this whole business. Okay.
Yeah, that's a good page to put them. Yeah.
But do we want, I guess we want, do we want sequence split and sequence replace here? They don't really belong.
Well, the splitting is a bit of comparison.
I think it's an obscure connection there. I mean, okay, hold on. So we've already got sequence-oriented things here. So that's in counting operations. That's all good. Okay, so here, I think sequence position does not belong here. And maybe what we do, yeah, let's do this. Elements of lists. Yeah, there we go. Sequence position, all good. So the only thing we might want to do is to put sequence position in here if we think it's that important.
Not really. I mean, as long as it is in some page.
Yeah, I don't think it's important that it's there. Okay, so then this one here, what I think we should do then where do we put sequence? So sequence split can go here. We don't need this separate finding and manipulating sublists, I don't think, because we've already got that in a bunch of places. So we could put a sequence split in here if we want to, or not bother. Make sense?
Yes, we could put it here, yes.
You suggest we put it in this list? I'm not sure it really belongs. I think those are more sophisticated functions. Let's put it down here. Okay, so we've got this. Okay, so now we have sequence-oriented operations, right? So now here we have sequence split. And that's where we've got replace part, but now here we can say sequence replace here. And what other ones belong in sequence-oriented operations on this page? Nothing, I think.
Do we have cases here?
We don't need it. No, we don't have cases there.
Okay,
Okay.
then that's fine.
Split a list at, how do we say it in the actual function itself? At the position of sequences, right? Split into sublists separated by it. Split a list
At subsequences matching a pattern. At sequences matching a pattern.
yeah, split a list at sequences. Okay. Replace sequences in a list. Someone on our chat stream is pointing out how horrifying it is that the words, that these functions that have the word sequence in them, yeah, don't actually deal with our sequence thing. You know, I have been trying to stamp out sequence for, what is it, 37 years, 38 years. It was a construct in SMP called NP for null projection, a really stupid name in SMP. And it was horrifying there, and it's horrifying, the semantics of it are horrifying in Wolfram language as well. And I would just be happy if we didn't have the function sequence. And we've been trying to get rid of that. By the way, what's happened to the flattened construct? Have we looked more at the flattened construct?
We have been exploring some details like whether it should be hold or
I think it's a nice construct.
Yes, it might help. It's just that the syntax is not clear yet, whether it should take a second argument with a head in which it splices and this sort of thing.
I see, and the head into which it splices.
Exactly.
Yes, that's interesting. I mean, clearly by default, it should splice into, well, okay. I would have thought, like nothing, it should be a list-oriented thing.
Exactly, that should be the default, I agree. But sometimes you need that operation in other heads, and then it would be nice to be able to control that.
Yes, I agree. I mean, I think it should take as a second argument the head into which, or the pattern of heads into which auto-splicing should occur.
Mm-hmm. Danny was suggesting that because the first argument is going to be a list, somehow the first argument could also indicate which head is looking for.
What do you mean? Oh, you mean, oh, I see. So if the first argument of flattened is an F construct, then what do you do? Yeah, you might as well be going into the F construct because that's, yeah, I mean, which is,
this is nice. The problem here is what happens if F is trying to evaluate. This would force us to have flattened being hold first.
Oh, but it's horrifying to do that. We do not want to do that.
Yeah.
We really don't want to do that. That will spoil the whole point of it. I mean, we're mostly dealing with a list. If that thing wants to evaluate, then it shouldn't be splicing. Well, how is it going to splice if it evaluates?
Right, but I mean, perhaps somebody is constructing a function in some weird way by
tough luck. Then they can do it themselves. I mean, I don't think we can provide for that. The value of having it evaluate is much greater than than some totally weird case which I can't even imagine yet.
Mm-hmm.
All right, let's just deal with the back pointers for sequence replace.
Yeah.
Wait a minute. Does sequence replace not point at sequence split, or does it not need to?
Not yet. I didn't update the ref page, but I think it should. Yes.
Okay, where?
Maybe the second. I'm not sure.
Sequence cases and sequence replace. So what's the difference between? Yeah, it probably needs to there. Oops. Ag. Okay. All right. Okay, so now let's just go through some of these sequence cases. Did we already point this to sequence?
So sequence replace, yes. Sequence split, not yet. So
Do we want sequence cases to point to sequence?
I think they should all refer to each other. So I could add those in. Sequence split will be missing for the moment for all of them.
Okay. And which other one do we want? Sequence position. Yeah, sequence position definitely does want to point to sequence. Sequence position.
After sequence replace, perhaps.
Yeah, all right. Problem is that these functions have a habit, we have to, not just because it's newer doesn't mean it's better. I mean, in other words, we have a tremendous habit, I think. I suspect if we did an analysis of this, that there is a preference for putting in functions, for giving pointers to functions which are new rather than older ones. Okay, so now sequence alignment. Does that want to point to any of these, and does it right now?
No.
No, I don't think so.
Points to sequence position, which is right.
Oh, lost sequence cases.
Let me just think for a second, because its sequence alignment is looking for common. It is breaking the thing. You know what? It should point to
split one, right?
Yes, it should point to the split, because that's what it's doing, basically. Yeah. And I think sequence split should point to sequence alignment.
Perhaps it does already.
It does. Mm-hmm. Okay, all good. All right, I think that's everything for these.
Mm-hmm.
Okay.
Good.
All right, what's next? Nearest to?
Yes. So.
Oh, have we got a problem here?
It's a small thing that Tony detected, but we can look at it after reviewing the page.
Well, does it affect the design?
It's not really the fault of nearest to. It's the fault of nearest. So it's something that we cannot change, but it affects a bit what Tony does. So so he was comparing nearest with take largest.
Yes.
And the point is that take largest returns the full key value pair, while nearest only returns the keys. And he was saying that for him, it would be nicer if nearest returned the full key value pair.
So why don't we just give it a property there, as you're suggesting here?
We could do that. I mean, it's not going to be automatic, the fact that nearest, I don't think we can change now nearest to return.
No, absolutely not. And nearest is returning the nearest things, not let's see. So walk me through this again. So the issue is take largest on an association returns. So this is not an association. Okay, I'm totally confused.
No, forget for the moment about the second part. The first part, the first bullet point is the important thing. The fact that take largest returns an association with key value pairs, while nearest returns just the keys, which I think separately they are both fine. It's just that Tony wanted to use take largest and nearest and nearest to in exactly the same way, the operator forms. And
well,
of course,
yeah, I know he wants to do that, because what he wants to do is he wants to be able to say entity of city, comma, city.
The property goes to, take largest 5 or nearest to 3. And for him, it's a bit of a problem that one returns an association, the other one returns a key. But he has solved that. He can work around that.
Well, wait a minute. What he's actually got to do for nearest to, what is the actual use case? Because nearest to, like the city nearest to Los Angeles or something.
Well, there is an example in the nearest to page. It's something like element whose density is nearest to 4.5 grams per cubic centimeter.
Okay.
And I think it's in applications or scope. Yeah, this one. So there we have nearest to that value. Now,
and what's the problem?
So internally, when he does the computation, if he used take largest 5, density take largest 5, he would get an association of key value pairs. While with nearest to, he gets just the elements.
Well, so in particular, if he says here, if we say the 3 elements nearest to, how do we do that? If I say this thing here, comma 3.
No, we don't have that. Oh, do we?
My gosh. Well, I have no idea what that just did.
This is probably not updated yet. He changed this recently.
Okay, fine. But so nearest to, I would have thought nearest to, let's take a look. Nearest to here.
Mm-hmm.
Yeah.
So no, the semantics is fine.
By the way, there's a typographic error. That comma isn't of the right type there.
I see. I'll change that.
Okay. And it's also wrong there. Okay. In any case, go ahead.
Yes. So from the point of view of an implicit entity, the semantics is fine because you can express what you want. Is from the point of view of using it directly, he has to prepare for some functions to return some operator forms to return an association, and some other operator forms to return a list of keys only. So he has to go then and look for the values and things like that. See, he has done that already.
Okay. So we shouldn't worry about it.
No. We just wanted to mention this difference between nearest and take largest, which behave in a slightly different way.
Well, right. I mean, because, okay. I mean, the point is take largest is a take-like function that takes pieces of a thing like a list or an association, and nearest returns what is nearest. And I think what you're proposing here is that in this case, it should return an association here, whereas nearest has various things it can return, like an element, an index, a distance. Why not have another one that says association that returns the association of key value pairs?
Yes, exactly.
But the association is then, what is the association in that case? The association is, I'm really confused. I'm sorry. What's the left-hand side of the association then?
Well, that's the second part I discussed there. The fact that depending on whether we fit to nearest an association or a list of rules,
it does a different thing.
It does, exactly. It's basically the same thing, but reversed.
Yes. Well, that's the same as happens in lots of other functions, like all the machine learning functions.
Yeah.
Okay.
So here we have to decide how to return this new property.
But you're saying both the element and the index. We're returning both element and index. Is that correct?
Yes, but we have to decide in which order. and whether it's
or
a
whether
list.
it's an association or a list of rules.
Exactly.
Well, so if we call it association, it's pretty obvious what it's doing.
Yes, that's why I was saying key value, which is kind of more association-like, while rule.
Yes, I agree, but what it's actually returning. Oh, I see. It's going to be a look. Normally, it is returning a list of results, is it not? All other
Yes.
things here return a list of results.
Indeed.
So if we had a property that said association, it would return a different thing, which is index arrow element.
Yes, but these properties are referring to the elements of the list, not to the whole object. So in a sense, rule or key value is more.
Yeah, but saying that it's an association as the outer wrapper,
Exactly.
is we also have to say that.
Yes.
I mean,
yes.
but this would make more sense to say elements plural here, given what we're now saying about association.
Yes. Well, this element is referring to each individual element. So these are properties of each individual object, and that's why we can put a list.
Okay, this is too complicated. Let's not worry about it right now. If Tony has managed to solve this problem some other way, I'm not sure this is worthwhile. Do you think this is worthwhile?
We don't need it right now.
Okay, fine. So let's keep going with nearest to. Did we write this before together, or is this a new thing?
I don't remember. I may have followed what we use in other operator forms, like equal to. Or...
And by the way, that should be definitely pointed to for here. Let's take a look. Yeah, okay. All right, fine. Surely this should be, well, I don't know why we're talking about predict and classify. Those seem totally irrelevant here. Why are we talking about those?
I don't remember.
I mean, does nearest talk about those? Probably, but that's for very different reasons. I mean, this would be more like a classifier function.
I see. We don't need to refer to them.
We do need to refer to nearest function here, and we definitely need to refer to equal to.
Yeah, probably entity itself or entity class.
Yeah, we can. Are we referring to that here? Actually, I would argue that equal to is really a much now let's see.
But probably nearest is clearly the first one. Equal to and some other operator forms could be the second.
Before we get to geo-nearest.
Yes. I mean, if we want to put the emphasis on the operator form, then certainly.
Okay. Are there any other operator forms that we want to? Why on earth does equal to not refer to? Oh yeah, greater or equal than. Right. Okay. Okay, fine. All right. So then we need back pointers here. What just happened? Why did that not work? Okay. We need back pointers on equal to. Probably here to nearest to. And arguably that should also be in greater or equal than. What do you think?
Yeah, why not?
I think that's useful. And less equal than. Okay.
Yep.
All right. Okay. Seems fine to me. Futureize. Okay, is it knitted?
In guide pages, no, it's not.
Do we have time to do this knitting, or are we going to run out of time if we? Let's do this. Let's see.
Let's put it in one of them at least.
Okay, so this thing goes right there.
Yeah.
Testing expressions, operator forms.
Yeah, that's perfect.
Although arguably, if we're going to have inequality and inequality, we should include nearest somewhere here.
What do you mean, inequality?
Well, here, look, between. No, I see. Those are tests. Yeah. All right, fair enough.
Yeah, we could have nearest in that first line, but the operator, I mean,
no, we
nearest
couldn't, because these are Boolean tests.
Oh, I see what you mean. Yeah.
But that does fit with these.
Mm-hmm.
Okay, so now where is nearest? Where does nearest show up? Let's look at nearest. Those are very bizarre. Oh my gosh, there's 69 results for nearest. What kinds of places should this show up? I don't know whether this is, I mean, I don't know how important this is for other things other than the implicit entity stuff. Where is the implicit entity stuff discussed?
Looking.
Knowledge base. You know what? We missed a bunch of things here. This is because here, where we talk about entities implicitly defined by property values. Oh, we've got greater than, less than, between. Okay, so that's the line where we need it. Is nearest to.
Yeah.
Actually, let's break those apart. Okay. Okay. All right, let's see if nearest correctly points to nearest to.
Probably not yet.
It does. Well, it does. It's right there.
It does. Okay. Yeah. Great.
All right. Anything else for nearest to?
No, I don't think so.
Okay. All right. What's next? Construct.
Yes, we have this pair, construct and carry, and construct should be the easy part.
I hope so. I had some ideas about curry, of generalizations of curry that were quite wild. Okay. Do we say returns or gives?
I don't know, whatever you prefer. Oh, yeah, the XXX should not be there.
I know. There's little to say, it seems, about this.
Yes, absolutely.
We should point to apply. We should probably point to curry. And shouldn't we point to a composition type thing?
Yes.
What should it point to?
I would say actually composition before carry. Apply, composition, perhaps map, and carry.
Somebody on our live stream is asking out of curiosity, how does our Wolfram Network folder work here? It's complicated. We do it differently for the code is in Git, and our documentation, because it's notebooks that contain things that Git doesn't find very friendly, like big images and so on, that's still in CVS. And I'm some of the things, some of the design documents are in Dropbox, but the way it works is I am extremely lazy and personally don't explicitly do checkouts from CVS. And so when I'm doing these editing sessions, I have a command line script that simply overwrites CVS, just forces back my changes into CVS. So that's the basic. Oh, somebody just reports that they just found a bug in GeoList plot. Okay. Interesting. Okay. Well, please send it in, or just tell us right now. Send it in. Okay. What else? Card function. What on earth? What else do we have to say here for construct?
It's a little. Well, I would link to composition and probably map.
What about the extremely obscure function operate? Does that have anything to do with this? I have no idea. Why are we looking? Why is composition relevant?
Because, well, I guess because construct comes from compose in a sense, and compose was a mixture of construct and composition.
Okay. By the way, where should I put it in this list? Map, scan. I would say probably it comes there.
Yes, or even before. Exactly.
Before level. Okay. So what are you suggesting goes here?
I would add composition.
What is compose list? That is a function we never use.
Yes, in fact, it's a bit strange that we deprecated compose but not compose list.
I think we simply forgot about compose list. That's really weird. Well, it's more useful, and I mean, compose is really useless because with the okay, so let's just look at okay, composition. Why is composition relevant to construct? How do you combine composition and construct?
There is an example in construct, which is trying to further down in scope in properties, I think. Exactly. Yes, so that's what the old compose used to do. So now the action has been separated into composition and construct, which is a lot cleaner. But in case somebody wants to do that.
All right, okay, I get it. Okay. Well, so then composition should refer to construct, probably at the end.
Exactly.
And construct should refer to composition. What on earth just happened there? Okay, let's defuturize. I don't think we have to make this function experimental. I don't think there's lots of ways it can go wrong. Let's hope.
No, this is going to be useful. Actually, the application examples are nice here because it shows how to do things that were, I mean, we would have to use hashes and things like that to do this before.
Oh, look, here's the thing that look, construct should function. It should refer to function.
Yes, yeah, that's a good point.
Actually, it should arguably refer to function pretty much first. Apply I think it should refer there to function.
Mhm.
I also think identity, somewhat bizarrely, should refer to this.
Yeah, why not?
Okay, and meanwhile, function, let's see, function. I think function should refer to this too. And function should also probably refer to curry.
Yes, absolutely.
And by the way, slot should refer to curry as well, would seem to me.
Yes. Though in curry precisely we try to avoid using.
I know, but that's the
slot.
point. I mean, if you're thinking about slots, then imagine curry. I mean, we don't deal with, by the way, we could imagine an interval construct in curry. We could imagine saying interval 3,7, which would give you, which would sort of scoop up arguments 3 through 7.
Mm-hmm. Yeah, I have a note at the end of the page discussing something like that.
Okay. All right. Okay. There's construct. So
yeah.
let's go to curry now, and then we've got to knit both construct and curry. The thing that I was thinking about with curry, I mean, the point about curry is that it's part of the sort of family of, I mean, it's a whole combinator. By the way, do we mention? Yeah, we do mention combinator there. Good.
Yeah,
go ahead.
The comment I have in the agenda is related to combinators. Perhaps we can have a quick look at it.
Okay, but by the way, this should come last.
Yeah, so I had problems with the phrasing of all of this. That's why I left the alternative form there in case you prefer it.
Okay, hold on. Represents an operator form of the function f. Why do you even need to say of n arguments?
Well, to make more explicit why we have that n there.
Oh, I see. I get it. I get it. Of the function f of n arguments, I think that's reasonable. I mean, look, I mean, you should say this, but in the notes to explain what's going on.
Okay, yeah, that's a good idea. So these 4 definitions are ordered in progressive, more complicated text.
I know. The problem with that first one is that people will say, what on earth are you doing? Why is it the wrong way around?
I see.
By the way, let's just look at, since somebody on our live stream with a seemingly Japanese username, which I obviously cannot. I could put it in and transliterate it, but failing that, I can't say who it is. Says that this is a bug.
Interesting. 2 Spanish cities.
And they're unlabeled. How can they be unlabeled? Why are they unlabeled? Because one of them is is it because one of them is a extended region and one of them is a point?
No, I think this is a genuine bug we have to fix.
That just involves the fact that it's 2 cities.
I'm not sure. We would have to explore. Okay. I would tell Brett's group to look at this.
I'm just for the hell of it, I'm just going to try this. That which should work, right? Oh, come on. What happened there?
Can you do entity list first to separate the two?
Yes, I mean this is the external.
Try changing class, entity to entity class. Oh, that works.
Okay, well that's two bugs there. So that's an entity, whatever that thing is, that needs to work. I think that's a new bug because I'm sure I've done that before. We've got 3 bugs flapping here. Okay. Okay, let's look at the 3 flapping bugs. We've got Lagos with its L missing, which I consider to be fairly minor and possibly unfixable in the current state of things. We've got the entity list thing, and we've got the 2-city problem.
Yeah.
I mean, I wonder what happens if I say, if I do this. Yeah, I think the problem is with one extended thing and one non-extended. That would be my guess.
Yeah.
Okay, in any case, irrelevant. Okay, thank you though for the bug report.
Yeah, indeed.
Okay, so curry. All right, well, let's defuturize curry. Are we going to consider curry experimental?
Yes, please. There could be extensions needed.
There could indeed. I mean, the thing that I was thinking about was named currying. I'm not sure it's quite the same concept. I mean, like, for example, with the neural net stuff, we have a lot of named ports that connect to other named ports.
That's a bit like introducing variables.
Well, okay, so here's what I realized this morning, actually, in our neural net meeting. What is the difference between named ports, which are like wires, named wires, and variables? The answer is wires have this property that the values flow down the wire and are gone, right? Wire is connected, the 2 ends of the wire are connected to whatever they're connected to, the value goes through the wire, you never see the value elsewhere. Whereas a variable has a separately managed life cycle. So in other words, the variable might be localized, it might, have its value localized and so on, but the variable has a life beyond the wire, so to speak.
I see. Interesting.
Right, that's the difference. Whereas, and what this is, if we were to wire things up through currying and so on, that would be a non-variable. It has no life. Like you can make a closure with, with a function having a variable whose value comes from outside the function. But if you are doing it with pure wiring, it's you can't do that. By the way, the person on our live stream, and I got to stop looking at this, is asking for a public bug tracker. You don't want that unless you want to spend your life going through. It is not an easy thing to figure out what's going on. It's there is a bug tracker, and it's, let's see what happens if I press develop or open bugs. What happens here? Oh, is that something assigned to me? Oh wow,
it seems so.
It's only one of it. That's amazing. Okay, well, whatever. Somebody should clean that out. That whatever that is, it's not going to get looked at. Okay.
So isn't then the wiring some sort of scoping which is very fast? It only exists.
Yes, it is, but it is essentially some functional version of scoping that still has names, but those names are more volatile than, it's not like a declared name. I don't know. I don't understand what it is exactly, but it's something, I think we've already invented, because what we're doing in neural net business is we're transitioning for a wire situation to a variable situation, just like we will also do that for the quantum computing case.
Right.
and we need to understand. But I think what we're seeing here is a case where we can imagine having a sort of a ports and wires version of any collection of functional programming things. And I don't quite understand that yet.
Right. So
I mean,
it's true that in function, for example, we have slot 1, which in a sense is a name. And here we are trying to handle things without that intermediate.
That's right, without names, which is what, that's what Schoenfinkel tried to do with combinators originally.
Exactly. And in fact, please, can you go to this note I have in the agenda?
Yep.
Because there I tried to construct the S and K combinators with carry, and K is trivial, but S, it almost gets there in this second.
Oh my gosh.
But you see, I have no idea how to combine the Y and C internally. And I think that's the important thing for the S combinator, and the thing we are missing with carrying, this idea of mapping things very deep into an expression, which we can do with function, because no matter where we have a slot 1, very deep in some other expression, the argument will get there.
Yes.
But with carry, we cannot do that. We cannot map, say, the variable C to the Y.
Well, okay, so let's just take a look at what this is doing. So you're currying. What the heck does that even do?
So let's look at K first, which is simpler. So K is saying, take 2 arguments and just map the first to identity. So we get back X.
Right. Take 2 arguments, return just the first of, use just the first of those arguments. The function is identity, we get back X. Okay, I get it.
Exactly.
Now here, somewhat bizarrely, we've got essentially a duplication of argument. We've got 3 arguments and we're duplicating the 3rd argument, the Z, which is correct. That's what we do.
Exactly. And then once
so
we have...
in the simpler version of this, what we will be saying is, given this, we have a 3 argument function, right?
Mm-hmm.
And what we will be saying by rights is #1 of #3 of
#4 now.
No, like that, right? That's what we would be saying.
Yes, but now we are feeding the 4 arguments to that function, because we have converted 3 into 4. So it would be...
Okay, but we don't, in fact, in this way of doing it, we don't need to do that.
Exactly. With function, it will be just exactly what you wrote.
In fact, it's just this.
Exactly.
And by the way, we should put that in the documentation, that case.
I mean, even without carry, it will work already, because function takes 3 arguments there.
No, it won't work. It won't work. Look at what it's doing. It's
I see. Yes.
This is, in fact, a perfect example of currying.
Yeah, exactly.
And right. So the issue is, should we be able to do, in other words, currying is one thing. Currying is the unraveling, the de-tiering, to use the SMP terminology, of those arguments.
Mm-hmm.
Right? That's one thing. Now, the second question is, how do we wire up those arguments? And that's what you're trying to do here.
Yeah.
And it's not obvious to me that the wiring can be done. Yeah, I mean, this is wiring without names. There's this big, thick book by Hank Barendrecht about lambda calculus.
Mm-hmm.
Right?
Yeah.
And, it's, I was looking at it at some point, and I thought, gosh, in the history of lambda calculus, somebody has got to have done better, with all of these, notions of beta reduction and God knows what else. This whole business of functions within functions and the renaming of variables, there has to be some functional way to do that. But in this book, it's just like, no, there's this weird De Bruyne labeling and so on. There basically isn't a solution that known in that whole literature, I think. So in 100 years of lambda calculus, I don't think there's a known solution to how to unravel these things without effectively having names. right? So that was, because that's the problem we're dealing with here, is how to deal with essentially, I mean, I suspect, okay, so here's another way to think about it. Another way to think about it is imagine it's just a graph, right? So, because that's what this is. This is a graph feeding, or a tree, actually, not a graph, a tree, because it's returning up to the root one function name, right? One value, right? So another way to think about this would be, forget all these things and just feed in as that first argument some kind of tree.
Mm-hmm.
Actually, maybe Xavier has is Xavier here? No. Yes. No.
Yes.
Maybe you have a thought based on your trees work about a tree that represents a function, because you've got trees whose nodes have functions on them, right?
Yes.
So what is the relationship between, is there a function tree effectively that basically eats arguments from its leaves? You see what I'm saying? So in other words, what we're saying here is one way to represent a function, any one of these functions, like the S combinator function, is to just say we've got a tree, and at the nodes of the tree are known functions of some kind, f, g, whatever else, right? But the leaves of the tree, labeled in some way, as yet unknown, the leaves of the tree are the input, are the inputs, basically. Did that make any sense?
So you want the leaves to be functions themselves?
No. I want the leaves to be the slots. The leaves are where the slots go in.
Or like placeholders? Or...
Yes, they're like placeholders, because that's what, if we wanted to represent this thing here in a way where we didn't have to explicitly name 1, 2, 3, the way I could imagine doing that is with essentially, let's imagine that this was the thing. If we said, and again, this is not a very good way to do it, but let's imagine we just had the tree form of this, okay? And that's not the right way to do it, but those things wouldn't be, what would those be? I don't even know what those would be. Yeah, those would be constructs, I think. What would those be?
Yeah, so there will not be a slot 3, but only one leaf. Is that correct? Sorry, two leaves, but not slot 3, like just a placeholder instead of slot 3.
Something like that, yes.
Okay.
Yes,
so
this thing would be, yeah, that would be, I don't know where slot 1 goes in here then. But what I'm suggesting is that there's a way of doing this so that the thing you have is not a thing with named variables. It is merely a tree.
I see.
Which implicitly has names inside it because of the way we represent, well, actually it doesn't necessarily have names inside it. It has to have something representing its unfilled leaf slots, right?
Yeah, so we have investigated this, and we had these 3 elements bracket, so nothing in it. And we thought that this could be used as a placeholder, exactly.
Okay, well, so fine. So then we've got exactly this. So we've got something with an empty tree element that represents a placeholder. So that is our answer, I think. That is what our nameless, in other words, what we could imagine putting in as a tree function, basically. That is, so in other words, what it would be is something like it would be tree function of a tree here. And that thing would expect arguments which correspond to the leaves of the tree.
But how do we know which argument goes to which leaf?
Well, I know, therein lies the problem, because we have to do we have to have an ordering of the tree leaves, right? And that requires depth first, breadth first, whatever else, right? But that's a traversal order we've discussed for trees for other reasons, if I'm not mistaken.
Yes, but because trees are kind of 2-dimensional, well, I don't know how I mean, they are not one
I
dimensional.
understand. It's not obvious how you do the ordering of those things. I mean, we could do it by lexicographic order of part numbers. We could do it by a bunch of other things.
Right.
But my point is that I think this is the variable-less representation of, this thing here, which you've managed to sort of hack together with a pure curry and construct. I think the correct variable-less version of that is a tree.
Mm-hmm.
And I agree that there's an issue about the ordering of, I mean, again, which smacks of variableism, so to speak, of variable numbering or something like this. But I do believe that the tree is kind of a generalization that I think this is right. And I think maybe that the generalization of that, when you have shared intermediate variables, is a DAG of some kind. Anyway, that's for the future. Let's put on our list, to look at tree function.
Okay.
Okay. Oh boy, I've got a completely different meeting that this is colliding with. All right, let's I need to get to it soon, and then I have got to. Yeah, I'm traveling this afternoon and this evening. So, okay, fine, no problem. All right, so let's go look at this curry thing. All right, so the question is whether to put this form first or not. I would like to not put it first because I think it's like so much of the why are you doing that? It's the wrong way around type thing.
Yeah, for some time we had a separate function, but now it has been removed again.
I don't think we need a separate function. I just think we don't want to put that as the first use case of this.
Okay, that's fine.
I wonder whether we want it as the second use case or whether we want it far down. Let's put it as the second use case. I think that's the best thing to do. It's hard to know. I mean, any of these things could be confusing. Okay.
Mm-hmm.
So do you want to, you are going to, okay, so these forms here, I think we understand what these are. K argument operator forms, so that blah, 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 blah. Now, are you proposing something with a span? Yeah, no. Sorry, it would be a span, not an interval.
We could. I have to think how that would work. I was thinking more in relation to what you have on your left, which is how to do two of these functions at the same time, but that gets a bit too complicated.
I think it's too complicated, but what I think is useful is the analog of hash, the analog of slot sequence for curry.
I see. I see. Mm-hmm. Yeah, perhaps a span can be done, yes.
All right. Okay, so I think this is reasonable. And now the only thing we have to do is to knit curry and construct onto the main pages. Where on earth does this go here?
With applying functions?
I guess so. Well, the very first curried operator form is probably curry itself. Okay, so here, okay, so I guess this is where construct goes.
I would put it with applying functions, not with functional composition.
Yeah, but this is applying functions to lists.
Oh, to lists. I see. I see.
Well, let's make the change here first, because we know we want that one. Function composition. Okay, well, hold on. So here, we clearly want, construct clearly wants to be here.
Yes, in place of compose.
That's an interesting claim. Right.
I mean, it could be farther down, but.
No, that's all right. Construct an expression.
Yeah. From head and arguments.
Yeah, from its head and arguments. Okay. Now, do we want to put curry?
Well, it says operator forms here. So where are the operator forms?
Well, there's a separate thing with operator forms, curried operator forms.
No, but I mean the title, it says function composition and operator forms.
Oh, okay, fine. All right, then.
So where are the operator forms here?
Here. Where are they? They're here, functions with operator forms.
Oh, I see, sorry, yes.
Let's do this. Let's have a delimiter there, and let's put curry here. Oh my gosh. Now this is the always problem. Of how to describe this.
Maybe turn a function into an operator form.
Okay. Fine.
I like that.
Okay, now where does construct go on this page, if at all? I think construct deserves to go somewhere here. Well, let's just put expression construction here. Why not?
Yep.
All right, and then what I'm going to do is put construct here. What did I say here? Yeah, right. Construct an expression from its head and arguments. Okay. We happy with this?
Yeah.
Okay. All right. I think we can declare victory here, except that there's clearly more. Somebody was asking on the live stream here, by the way, about our tree thing. Is it just about injecting data into the computation graph? Yes, basically. I mean, this is defining, well, it's a little complicated because one of these trees is a symbolic representation, an unevaluated representation. This requires a bit more thought. I mean, this is kind of like the quintessential issue of, yeah, the difference between, there are these two forms of recursion that we always end up having. Well, never mind. This is a long discussion. I mean, when you have some thing where there's one form of recursion, which is repeated evaluation of something, and the other form of recursion is going through an expression tree. Yeah, those have a complicated relationship. All right. Anyway, it's I think this is great. So good. I think that's it. Let me just push back. Since somebody was asking about how this actually works, I will show the horrifying thing that actually happens here. This is pushing back the things we just worked on. Very primitive, really. Okay. Right. Let's okay, wrapping this up. Actually, I'm about to go to another meeting, which is also on a live stream. Oh, somebody is making a suggestion here. All right, one last thing we're going to look at. A nested tree. Okay, let me copy this out. We have 2 comments here. A nested tree could be used. Yes. Yes, well, we have trees. We have a function that is called rule tree, right? That turns that into a tree. Is that correct?
It won't be the same syntax. Yes, it's based on rule, but it's not separated by comma like that. You directly linked a parent to its children with rule, so there is no comma separated expression.
Directly linked. Okay, but by the way, okay, this other comment, way to specify mixed arity of a function. I don't think that's right. I think that this is, I'm not sure quite what that is referring to, because
so carry will not express a function of different arities. It has to have a definite arity. So with carry, you cannot say a function of 2 or 3 arguments, because they need to.
Yes, I understand. Right. I mean, I don't think that makes any sense for Curry. I don't see how Curry could ever deal with that, because
Excellent.
Curry doesn't know. It is a primitive, dating as it does from the 1920s. It is a primitive form of functional application. Boy, that must have been confusing. I mean, to people who think about math and think about functions as mappings from spaces to spaces and so on, the whole business with, the Hilbert style, and then Schoenfinkel style combinator thing must be, I mean, I can see why the, obviously the Poincaré style of mathematicians with the spaces to spaces business, very different from these structural things. Anyway. Okay, but let's just look at this for a second. So,
yeah, for the first of our rules tree, we will need something like 0 goes to 1, goes to 3, goes to list, and so on. But the idea is interesting. Maybe we could have an expression, because from expression tree and tree expression, we can go back and forth from a tree to an expression.
Yes.
So we could have an option like float or something like that, because we are using structure, the idea of structure, on how to interpret a tree to an expression. So we could have something like that to interpret a tree as a function. That
I
is waiting
understand.
for slots. Yeah.
Yeah, I think that's interesting. But so you're right. I mean, it's really a way. It kind of begins to bring together, sort of in the visual programming metaphor and so on, where we have graphs representing. I mean, okay, so one thing that we obviously have, we can easily represent a chain of functions, right? That's it's just a composition, right? We have a very straightforward way to do that. So the question is, what's the generalization we say FGH of X, right? And we have that. The question is, if you don't want the data to flow, well, there's two problems. First of all, if when you have multiple legs for each function here, I mean, look, this is another rediscovery of the exact same thing that one talks about, right? This is like tensor calculus too, where things have multiple legs and they have to be knitted together correctly. And the tensor stuff is very similar to the neural net stuff, although not quite the same, because while neural nets are using tensors, they're not using it in the same way. Well, am I making any sense? I mean, okay, how does this relate? Okay, our physics moment here. How does this relate? So when we look at like tensor expressions as represented by like the whole Penrose diagrammatic thing, those are mostly contractions. Is that true?
Yes, indeed.
And what is the relationship between a tensor contraction and any of this kind of connecting an argument here, and this sort of computation graph thing?
So the contractions basically would be like having the same variable simultaneously in several places. So you need to say somehow this variable here and this variable here are the same variable.
Right, but that's exactly what we've got with these wires.
Exactly. So that's a contraction. It's just that in tensor case, you always impose that there are two contracted, but you could imagine there are many of them contracted simultaneously.
And why is it the case that in tensor calculus that you only ever have, I mean, usually with tensor calculus, you're doing the Einstein summation convention on the contractions.
That's a possible notation, yes.
Right, but that's usually in the contraction. That's what you mean you're doing, isn't it? That you're tracing over that contracted index. I mean,
yeah.
Whereas in the more general case, one could just say those indices have to be the same but are not summed over. Or am I getting confused here?
Well, yes. The difference is having a table versus having a sum. So the notation for table and sum are the same. So you can have indices repeated, and you can have, and then if you put around the whole thing sum or table, in the tensor case is sum, in this other case is more like table.
Right. There's a nice unification that we can do here, but it needs more work. This is going to be fun, but not for today. Unless you have a last thought. Go ahead.
No, I have a notebook I can show you at some other point dedicated to this unification, in which you can have a general head, which is neither sum nor table. And it's quite neat. I will show you some other day.
What do you, now I'm curious what on earth you mean by that. So
imagine we have table and sum, which takes indices, and then the expression in the first argument can have repeated indices or not.
Okay.
Now, imagine that you have a function that can take other heads, not only table and sum.
Oh yeah, right. We've thought about that before. In fact, that was a design in version 1, and in fact, it even had a name.
I see.
What was it called? It was a generalization of sum and product and all those kinds of things.
Exactly.
So it is a bit like outer, but it isn't outer. It's something. Yes, I remember that was it had a name. It had a name. It's probably in the yeah, well, maybe finally now after 30 years we actually need that function. All right, time to go to the next meeting.
Okay.
Okay, see you later.